Hi, my name is Scott Mill, President of National Energy Technology. Today I'm going to demonstrate the effectiveness of our superior refrigerant lubricant supplement as compared to the standard Senosol 3 refrigerant oil that 90% of all HVAC refrigeration compressor manufacturers use when they create their equipment. Manufacturers make a one-time installation of this inexpensive product into the closed-loop system along with the ammonia or HFC-based refrigerant. System oil is critically important. It will vaporize and travel with the refrigerant, lubricating, preserving seals, bearings, and other vital parts. This piece of equipment is an ASTM Felix lubricity testing machine. As evidenced with this device, our patented supplement oil has a 1,500 times higher lubricity rate than the standard product. The higher quality oil is specifically blended to match your system, and it can extend equipment life, reduce running amps, noise, maintenance, and oil fouling. Oil fouling, as it's mentioned in the ASHRAE Handbook 1985, will impede heat exchange and reduce system efficiency. 7% in the first year, 5% in the second, and 2% every year thereafter. I quote from their book. The vapor entering the condenser often contains a small percentage of impurities, such as oil. This oil forms a film on the condensing surfaces, creating additional resistance to heat transfer. Our oil is formulated to bond on a molecular level to the metal alloys that the refrigerant lines are made up of, replacing the insulating oil and restoring peak efficiency. The molecule will coat, but not insulate. And it's so slick that the cheaper oil won't stick. The end result is more cold air and a reduced delta T. So without any further delay, let's begin our experiment. In this machine, when I get it running, I'd like you to notice a few things. First of all, with this arm, we're going to put pressure on this wheel as it's turning against this brand new bearing. It's going to cause a lot of friction. You might notice some noise, some heat's going to build up, maybe a little smoke. The amps will begin to raise, and the engine's going to stop at a particular torque. So those are the things I'd like you to notice. First, we're going to run it dry. You would never do this with your air conditioning equipment, but it's going to stand as a nice basis for our test. Okay, I'd like you to notice where the engine's choking out. It's generally about 25 pounds of pressure. Notice the amps spike. The amps will go up significantly as the engine goes under strain. Let's try that one more time, see where we are. About 26, 25 pounds of pressure. Now what we want to do is add a little bit of the manufacturer's oil. Just enough to make sure it's on the wheel. And it is, we have a little oil there. And now we're going to try this experiment again and see how far we can get. Notice the running amps as well. It's building up a significant amount of heat, tension against that wheel. Let's see how far we get. About 25 pounds of pressure. We'll try that one more time. Every time it'll be about 28, 29 pounds of pressure. Now what I'd like to do is try to add a little bit of our supplemental oil. It really goes in at about a 5 or 10% solution. Sure, our wheel is coated. Looks good. We'll see what impact that has. pressure I can really put on that. You'll also notice the amps don't go up as much as they were before. We'll try that again. Pretty much got my wrench maxed out at this point. And I just can't get the motor to stop. You'll notice we also have less amps throughout the whole experiment. I'll show it to you again. That's a significant difference in noise. Now through that experiment, you'll notice we put a pretty big divot in this bearing, and it's kind of hot. I'm going to turn the bearing 25 degrees. Let's take a look and see what it does now. Putting a lot of pressure on that. And as you can notice, we barely have a divot in our bearing. It's not as hot, it's polished off, and you can barely notice any wear. Now, I know you would never do this again, but we made a claim earlier that said our oil molecularly bonds to the metal. So what we want to do is wipe off some of this oil. We're going to run it dry and see what results we have. Let's even turn the bearing, get a clean surface on there and see what we get. We're up to about 65, 75 pounds of pressure there. Let's try it again. So as you can see, even dry, molecularly coated, our oil does a much significant better job than what the manufacturer is using in your equipment. So extend lifespan, reduce maintenance, and reduce your energy. It reduces the delta T inside the unit. If you have any questions about this or any of our other advanced strategies, please feel free to call us at National Energy Technologies. Thank you.